So for this problem, it says that an object moves from point A to point B, as we see here, moves from point A to point B. And the first question asks, what is the work done by the normal force? Okay, so this is a pretty easy one. We know that the normal force in the direction of the displacement is always going to be zero. It's always going to be zero because it's very simple, because the normal force is always going to be perpendicular to the direction of the displacement, right? And that means that it can't do any changes to the kinetic energy, so it's always going to be zero, right? And now for part B, it says what is the work done by the weight force, right? So we already know this from before. The weight force with this is going to be the work equals mg y1 minus y2, and the mg is going to be a positive because it's going in the direction of the displacement. It's going down, right? So yeah. Okay, now C is asking what is the speed at point B, right? So we can see here that point B is right. Oh, oops, sorry, I think I messed something up here. No, I think we're all right. Okay, so we can see here that point B is right here at the bottom end, right? Okay, so what does that, what's the speed here? Okay, so to find that, we need to work with the kinetic energy as well. Okay, so the work net is equal to the work done by the normal force and the work done by the weight force, and we know that the normal force does zero work plus the weight force, which does this much, mg y1 minus y2. Then we know that the work is going to be equal to the change in kinetic force. This is the kinetic force, and this is the weight. Mg y1 minus y2 is the weight net, which is equal to the change in kinetic energy, which is this right here, half of mv final squared minus half of mv initial squared, right? Okay, so then we know that in part B, in the object B, that it's all the way at the bottom, so we know that that y2 here is gonna be zero, right? So that's what happened here. We converted it to this, and now we just have mg y1, and we know also that the initial velocity is gonna also be zero right here, and this is zero, then all of this expression part of the expression is going to be zero. So now we're left with this part, just mg y1 equals half of mv v final squared, right? So now we just solve for v, and then we end up with this expression right here, and this would be the speed in point B. V final is the square root of 2gy, and we can see that this was very familiar to a problem that we saw before. Yeah, and that's it for this example.